So yesterday we have seen what do you mean by distributed version controlling system, okay, and what are the features of it, and what is the difference between a distributed version controlling system as well as server-centric version controlling system, okay. Then after that we have chosen Git as our version DVCS2, okay, and we have seen how many ways we can host the Git, okay, and I explained you what do you mean by on-premises Git provider as well as a cloud provider, okay, and as part of the cloud-based one I showed you GitHub, okay. So how do we create an account in the GitHub and how do we create a repository and how to access that. Then as part of the on-premises server, okay, we use a Git server to set up our on-premises Git server, okay, and we installed it, we started on a Linux machine and we could able to see the dashboard like this, okay, and the default username password to log into this dashboard is admin, okay. So once you log into the admin, you just get into the repositories and try to create a repository here, and you try to clone this, click on this repository and it will give you a URL to you, and this URL SSH URL, okay, or HTTP URL, you copy it, and in your machine, it can be Windows or Linux or whatever, a developer machine, okay, you have to install Git Bash, okay. So once you install Git Bash, you just try to search with the Git Bash, you can find a Git Bash terminal and try to open that Git Bash like this, okay. So this is a Git Bash terminal, Git practice, and try to clone that, okay. Clone that URL, it will clone you the local, it will get a copy of the remote repository to your local machine, and that we called as the local repository. And the architecture also explained yesterday. I don't have the diagram at the moment, but we discussed, right, how it looks like, okay. So now after that we have seen some basic commands. How do we push the code, how do we pull the code. This is what your remote repository, guys. Remote repo, okay, and these are our developers, okay, and when they clone the repository they will get a copy of it, okay, and this copy we call it as a local repository. Alright, I'm just trying to review the same session yesterday, whatever we discussed, and these we call as a local repositories, local repo, okay, and this operation we call it as a Git clone, okay. Now the thing is, once you clone it, right, you work on your local workspace, okay, and you might be thinking, where is this local repository in my Windows machine, okay. When you clone your remote repository, right, see, Git practice is the one, and DevOps is the directory which is cloned by your remote repository, okay. When you clone it, right, the local repository and the workspace, see, this is what your workspace, okay, workspace. You might be thinking, when I commit it, right, you are saying it is going to local repository, okay, but where exactly it is going? Where is my local repository? And let me tell you one more thing, guys. You cannot see the local repository, but it exists. It's hidden, okay. So what is hidden is, can you see this .git folder, okay? This is called your local repository. When you clone it, it will create it, okay. And this, whatever the space here, you create a new file and all, this we call it as a workspace. Suppose let me create a new file called hello.txt, okay. I just created a new file called hello.txt. So once you created it, so whenever you create a new file, right, okay, so typically when you're working with a Git, you need to understand how many state it is, okay. Let me take another diagram. This is one diagram, okay. There are total 4 states are there, guys, okay, when you're working on Git. I'll explain you one by one what are all those states. Okay, first state is untracked, okay, unstaged, or you can call it unstaged, okay, unstaged file. So whenever you create a new file, okay, whenever you create a file, right, this file we call it as an unknown file or untracked file, okay. This, when you create a file, this is unknown for untracked file, in your workspace. Now right now at the moment, okay, you created a hello.txt. Now you get into this folder, git status. Try to run a command called git status. Now can you see this hello.txt? This is a untracked file. Okay, so this is the first state of sending a new file to your remote repository. So once this is done, okay, once you created a new file, now the second thing is what you're supposed to do is you have to make it as part of your workspace to commit that file to your local repository. Okay, so what you're supposed to do is next you have to run a command called git add hello.txt. Now when you run this command, what will happen, this will become a tracked or staged file. Okay, this will become a tracked or staged file. So you might be thinking, when I add it, right, okay, what command you used here, guys? svn add. Okay, sorry, not svn. Okay, it's git add. When you run a command called git add, it adds the file to your local workspace. Guys, when you run this, right, you're still over here. Okay, these two states, right, you're still over here. I'm just trying to explain you, still you're in a workspace only, right? Now once you add it, try to run the git status command. You can see, it is a tracked one. Okay, can you see? It's a staged one. Your branch is up to date and you can find a new file. This is a staged file, right? Now once you stage it, okay, to push it to your local repository, okay, to push it to your local repository, what you're supposed to do it, you need to run a command called git commit. This you know it anyway. Git commit added hello.txt, some comment. Okay, now when you run a command called git commit, then the file will become as, okay, now the file we called as the state we called as a committed file, committed state or committed file. Okay, now to make, and this time the file is in where? In your local repository, guys. Okay, this time the file is in a local repository. And which command we used to send it to your local repository? Git commit. Remember the commands, guys, how it is moving. This is really important. If you can understand the structure, you understand everything. Okay, and the next thing is, once it is committed, okay, now still the file is within your machine only. After 3 stages also, created a new file, added the file to workspace, committed to your local repository. Okay, but still the file is within your machine. Now if you wanted to share your file with somebody else, then you need to push it to your remote repository. Okay, so the next state is, this is what your remote repo, right? Okay, now push it to your remote repository. What you are supposed to do it, you have to push your file to remote repository from local repository. So now to push it over there, you will be using a command called git push. You got my point? So look at this. So these are all the 3 stages, okay, are within your machine, okay, within your developer machine, wherever you are there. Okay, so this is your machine, right? Now when you perform the git push, this will be pushed into the remote repository. Guys, any questions with the commands and the the flow which I'm trying to explain? There are 4 states in your git workflow. Okay, one is untracked, tracked, committed, okay, pushed to the remote repository. That's it. If you understand this flow, that's more than enough. You understand the distributed version controlling system, or Git version controlling system. Okay, any queries with this flow? Did you get it? Yeah, Mahendra.
Yes.
Okay. So now with this entire flow itself, you know all the basic commands, guys. There is nothing over there. Now suppose if this guy wants all those changes, right? He needs to run a command called git pull. That's it. If he runs a git pull command, he will get all those changes. Git pull. Okay, that will give you all those changes. Now I'll quickly walk through with some document, guys. What is version control system? Blah blah blah. It's a technical definition, guys. You just read it. I'll already send this document to you. This is really nice and handy. Yeah. Next thing is, repository. Okay, when you're committing some changes to repository, right? Okay, just like in a SVN, okay, even in Git also it maintains some versions. Okay, just like in SVN, in Git also it maintains some version. What exactly I'm trying to say is, in SVN, if you remember, the version started with a 0, 1, 2, 3, 4, and those we call it as a revision numbers. Am I right? Okay, where am I? Like SVN, okay, in Git also there is a versioning, okay, and these versions we call as sha1sum, okay, but in SVN what do you call them, guys? Revision numbers, right? In SVN you call them as the revision numbers, but in Git we call them as the sha1sum, and these sha1sums, okay, these sha1sums are unique. Okay, what do you mean by unique is, once you have a sha1sum, that will be unique, that will never repeat it. Now let me show you what do you mean by sha1sum now. Okay, so now once you committed something, if you want to see your history, that's what we use SVN log, right? Now same git log, guys, there is no other command, it's the same command, only thing instead of SVN it is a git log. Can you see the log? This is our yesterday's initial commit, which is done by admin when you are creating the repository. Like readme file it is added, right? That is done by the admin, okay, by git. Now this commit I made it just now, February 4th. Chiranjeevi add hello.txt, and the revision number is this yellow color one. This one is called the sha1sum. It's a alphanumeric, some 32-bit digit. Okay, this is the alphanumeric one, and that will be unique. That will never repeat it. Okay, so for every commit transaction, it will keep creates for every transaction it will keep creates a sha1sum, and that will be unique. And if you wanted to, like, go back to that state at any point of time, you can update to that sha1sum and you can go back. Okay, so if you want, I can show you an example how we did it in your STM, right? So suppose this is what the file system at the moment in your local in your repository. Okay, now if you go back to one revision back, okay, how do you go back to one revision back? Simple thing, copy the sha1sum. You know, to copy entire sha1sum, first 6 digits, sorry, first some 6 digits are enough actually. Copy. Now if you want to go back to that state, git checkout, guys, checkout is having a different meaning here. In SVN, git checkout nothing but getting from your remote repository, but here checkout nothing but update, like SVN update. You remember SVN update command? It updates to a particular revision number, right? We used to go SVN update -r1 or -r2. Similarly, in git, to go back to the particular revision number, we run a command called git checkout and provide the revision number, or you can call it the sha1sum here. Now I given the sha1sum. Now go back here. Can you see in your first revision number what do you have it, guys? Only readme. Okay, you don't have anything else over there, right? So that's how you can go back. Now if I say git checkout, okay, head is nothing but the latest revision number. That's it. Now when you check out head, right, where is the head? It doesn't have, okay guys, it's not head is like, kind of in SVN it is the head, but when it comes to the git you have to say master. Head is also there, but that is only for the particular branch level. Okay, now when you say git checkout, now it is git checkout master, it comes to the your original state. Now your hello.txt is back. Okay, so what I'm trying to say it is, I'll explain you what is master and all later, but try to run git checkout master, that will take you to the latest one. Okay, so this is versioning in your git. Okay, it's a sha1sum is created, and you can see what is the sha1sum and all, and this is the architecture I already explained you. What is the remote repository, what is the local repository. Okay, you should be able to explain yourself now. You just go through it. Working tree, and this step-by-step flow also explain you what is untracked, what is staging area, what is git repository. After you push, where it will go. Okay, and this is what your commit sha1 id. Okay, how your log look like. Okay, in your git log, right, what are all the things you have it, guys? Here git log, you have a revision of sha1sum, author, and date and file name. See, sha1sum, object id, author, committer, commit message. So all this will be there. So once you install a git, when you clone a when you clone a repository from your remote repository, I told you to, like, create your username and a password. These two commands yesterday we already done, if you remember. Okay, if you want, you can just try to copy this and run it over here, it will show you which user is there over here. Sanjeev, my username is there. Okay, what email ID is there? You just copy this. Don't give the username. If you give the username, it will set that username. This is what the email ID is there. Okay. So once you set up that, then you start with your the commands, all commit, add commands and all. Okay. So this document is that's it. Okay, to show you some basic stuff. Now let me explain the rest of all those commands, guys. Okay. So there is one more command is there, git remote -v. Okay, so what exactly git remote -v will show you is from which repository you clone this local repository. See, from which repository you clone, guys? 192.168.33.10 blah 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 something, right? Devops.git. So from this repository you cloned it. Okay. And one more thing, and I told you yesterday, this is a distributed version controlling system. You can push it to any repository from your local workspace, right? See, this guy can push it to anyone else repository, right? Suppose I have another repository over here, I can push it over there. So how to push that? That I'll show you now. Okay. So what you can do it, first of all, you should have the other repository details here. Okay, so let's create one more repository. Okay, so what I will do, I'll make use of the same Bitbucket only. Only thing is I'll create a completely new repository, guys. Here, create a new repository, say ABC, some repository. Okay, so sample repo, just create it. Now look at this, I created a sample repository, right? It doesn't have any code now, it's empty, not even a hello world is there. Now I'm taking the repository details, come back here, git remote, add origin 1, paste it. Okay, now what I did it, if now you run the git remote -v, see I added origin 1, another repository to my local repository. Okay, a reference I added which is abc.txt. Now what I will do, git push origin or origin 1. Okay, I'm doubt this command is not proper. Let's try to run and see. No, this is not correct. I think it is git push origin 1. Okay, admin, that's it. Okay, so when it is not an origin, right, you have to explicitly say the new origin name. If it is a default origin, you don't need to provide the this name. Now you come back to your git repository, guys. See, there is no data over here, right? Now you try to refresh. Can you see this? You have both those changes and you have both those files. Hello.txt readme in the ABC repository. Did you get it now? So you can push your repository to anywhere. Okay, that's called a distributor. So there is nothing like you have to push it only to your concerned repository. So there are two now right now. There Devops is our actual repository and this is a new repository which is created and we push from our local repository. So this is how a report to repo communication can happen. Okay, and yeah, what next? Okay, so let's see few basic commands of git. We have seen clone, add, blah blah blah. Let me show you few of them, like git remove, remove and revert. Revert is checkout on. Okay, checkout is already done, log is already done, remote is already done now. Okay, and remote add is also done. What else are there? Okay, I have a document. I'll try to open this document. We'll follow this document and do it so that you won't miss any of the things. Not this. This is git setup. Okay. Devops, git practice, okay, git part 2. So typically I follow this document. This is myself I prepared just to don't forget any of the commands. And we have seen the how to commit, how to push, how to delete it, RM. Okay, how to delete. It's pretty simple. Now I wanted to delete a file. Okay, I want to delete the readme.file. Just delete it. Okay, and git status and git commit. Okay, git commit -m. Sorry, git commit -m. Deleted the readme. Right now, once you delete it, you can push it. Unless you push it, you won't be finding the changes. Now, git status is a command that will show you what changes you have it over here. Okay, I don't have any changes over here. It's clean and green right now, my repository. And Now git log. Now you look at this. You have one more commit over here. Deleted the one. Okay. But if you go back to your remote repository in your DevOps, you still have this. Okay. This is DevOps, right? Did we push it? Okay. I think we did not push to the remote repository yet. Let's try to push it. Just push it. That's it. Now you have three commits. In one commit we add hello.txt, another commit we deleted readme, okay, and you look at it, you have ultimately hello.txt file. Okay, that's what the rm command and git push command. So what else are there? Git log. So git state log will give you detailed log. If you want a short log, git log hyphen one line, or can you see one line log? Only 6 or 7 digits of SHA and sum and the commit message. Something like, easy way. And at the same time, you can get the log of one particular file. Can you see this? It's a log of only that particular file. Okay. And if you want a log of a particular user, okay, so hyphen author equal to admin. So admin, how many comments he did? He committed only one. So how about the other authors? Okay. So you can see like the other author is Chiranjeevi. You can see these two commits are committed with this user, right? So this is how you can like perform all these commands. It's like a self-explanatory, guys. If you run the git short log, it's another type of format. Log only. Only thing is how many commits done by this author, two commits, and how many commits done by this author. Okay. So this is how you can get it. And remote hyphen v we already seen. Remote hyphen v will git remote hyphen v will show you what are all the remote repos. Okay. Git remote hyphen v. So right now we have two repositories, DevOps and ABC. Next, let's move ahead. And okay, now we are at the branching, guys. Okay, so when you are discussing about the branching, let me show you how exactly the Git is structured. Okay, so when it is SVN, right, there is nothing like a branching tagging with respect to SVN repository. Those are all we created, trunk, branch, stacks, and all blah blah blah. We created the structure and we managed everything. But when it comes to the Git, okay, Git default has some structure. Default, okay. When you create a repository, assume this is what your repository is, okay, like DevOps repo, okay. When you create a repository, it is an empty repository, but it has something like this. A default branch called master. This was the default branch, okay, and apart from that, it has another location called branches or branch, okay, and another location called tags. Okay, one is a master, one is a branch, one is a tags. Okay, now right now what are all the commits you are doing it at the moment, okay, are default going into your master, okay, and the log which you're looking also is a master, guys. So all the commits you are doing over here, not anywhere else. Okay, so every commit you are doing over here. This is how your repository is structured. Now to get into the branching stuff, okay, to implement the branching strategy, how we create the branches and how do you merge all those stuff, we'll see. Okay, I'm just saving this diagram so that I need to create another one. DevOps, Git practice, Git art. Okay, create a new one. Okay. Now, as I told you, like the default branch is a master. So how do you know whether it's a master or not? Guys, look at my prompt here, git bash. In a prompt, right? What did you see here? Master, nothing but you are in a master at the moment. Your default will be in a master. Okay, so when you see the git log and all, this is all in the master branch only. All this commit and the source code is there in the master only. Now if you wanted to create a branch, you have to run a command called git branch. Okay, so I would say release 1. My branch name is release 1. Okay, so what do you mean by git branch release 1 is, now I have created a branch called release 1 from master. See, if you want to create a branch from so-and-so branch, right, you should be there in that branch first. So where am I right now? I'm in a master. So if you try to run a command called git branch release 1, it creates a release 1 from master. Okay, if you want to cross check whether branch is there or not, branch is created or not, okay, try to run git branch. Can you see release 1 branch is created, and right now hashtag is nothing but on which branch you are there at the moment. I'm there in the master branch at the moment. Okay, now to switch it to another branch, what you're supposed to do is git checkout. Okay, release 1. That's it. Now I switch to release 1. If you wanted to believe it or not, can you see here? I'm in the release 1 branch now. Okay. Now diagrammatically, now I wanted to show you like how it looks like. Guys, treated this line as your repository commits. Okay, and this line is your master line. This is your master path. Okay, in this master branch, you made some commits. Let's put some dots here. 1, 2, okay, 3. Now at this point of time, what you did it, you created a branch called R1. Okay, a branch nothing but a separate location to work. Okay, so when you create a branch, you have your master path and you have your branch path, and this branch we call it as a release 1. Am I right? Okay, now this is what your master one anyway. Now it's up to your choice, where do you want to work, as you follow which process. It can be parallel branching or sequential branching, doesn't matter. But this is how the Git allows you to create a branch. Now I created a branch. So to work on a release 1 branch, what I'm supposed to do, I need to check out to release 1. Now my cursor is there in the release 1 branch. Now I want to make some changes over here. So look at this, hello r1.txt. I just created a new file, guys, here. Okay, and git r1.txt. Okay, and commit it -m. Okay, before committing it, guys, I want to show you the log to you. Now the release 1 branch is having an ancestor log. Ancestor log nothing but its history. The master log is continued here. These 3 commits will be showing in the release 1 now. Okay, now let's try to commit in release 1. Okay, added r1.txt in release 1. Okay, now you look at the log, git log. Can you see added r1.txt in the release 1? So total how many commits here, guys? 4 commits. 3 are from ancestor, which is from your master. Okay, carried out to your branch, and this is your branch commit, right? Cool. Just leave it. Now you're done with your one change. Okay, and that change I'll be marking it over here as a 1 dot. Okay, I made one change. Now suddenly, like I got a requirement to work in master branch. Okay, so to switch it to master branch, simple command same checkout. Okay, checkout is a command to switch between the branches. Okay, now you checked out to the switch. It's not only switching between the branches, you can make use of checkout to switch it to a particular SHA-1 number. Nothing but if you have a region number, the SHA-1 side, different set of log SHA-1, you can go back to any SHA-1 with the help of the checkout. Okay, now I'm in master. Now try to run a git log, guys. Guys, can you see in a master it is showing only 3? Okay, only 3 entries here, because these 3 entries are part of your master. The R1 commit doesn't belongs to master. It's completely separate. So if you're in master, when you run a git log, it will show you only that particular branch log. If you're in release 1, if you run a git log, it will show you that particular branch git log. So that's how it shows. So ultimately, with respect to git, right, everything is there in your repository. All the branches, master, everything is there. Okay, now you created a branch, right? Okay, now this branch is there where in your local repository, but it is not there in your remote repository. You go to your browser, this is what your remote repository. Okay, you don't have any branch over here. If you have a branch, then you should be able to see it here. Actually, there is no branch here. Okay, so now to push your branch to your remote repository, what you're supposed to do it, first you check out to your branch release 1. Okay, what happened? Anything wrong? Release 1, or what is it? Spelling mistake. Check out release 1. Okay, now I'm in release 1. To push a branch, okay, if you just use the git push, it will default push your master branch, guys. It will not push any other branch. Okay, so to push your release branch, what you're supposed to do it, you make use of origin. So which repository you're pointing? Okay, git remote -v, right? See, there are two repositories are linked to your local repository. So which repository you want to push it? I want to push it to origin. Origin nothing but your developer repository. Okay, if it's origin 1, it's a ABC repository. Origin 1, and what is the branch name? Release 1. The branch name you need to provide. That's it, guys. It is pushed to your remote repository now. If you want to cross check, you can check it out. The branch is available over here. Try to refresh. Okay, guys, did you see branches was not there earlier? Now a branch has been created, which is a release 1. Okay, and the master is a default branch, right? So release 1 branch, and the latest commit is what? added r1.txt. That's it. Okay. Now go to the tree, and this is what your master branch. Okay. If you wanted to look for your, what is it? This branch, right? Release one branch. Just click on it and click on the tree. You can see like r1.txt. This is how you can look into it. Okay. So now I know how to create a branch and how to commit the things into the branch and how to push it to the my remote repository. Now if you want to make a couple of more changes, now what changes you have it? You add r1.txt. Let me add some changes like echo hi I'm from r1 team. Okay, and this I'm pushing into hello.txt, a modification. Okay, and make one more. Just try to add this file and commit it. Okay, uh, made some changes in realize one branch. Okay, so I made one more commit, and this also I can push it to my remote repository. Say push command is same, guys. That's it, I pushed it. Okay, now if you try to refresh and look at the log, you can find, see hi I am from r1 team. So this data you have it, but go back to summary and click on the master. Okay, in master tree, what do you have it? You don't have, it's an empty file, of course, right? It's an empty file and there is no r1.txt. Okay, now I made one more commit over here. So once you're done with your release, okay, once you're done with your changes, you're done with your release, okay, you're finished. Now what you wanted to like, get all those changes back to your master, right? In those scenario, what you're supposed to do, you have to merge, okay, your branch with your master, okay. You have to merge your branch with your master so that when you merge it, right, what will happen? Your master will get these two commits are there, right? These two commits will be merged with your master, and your master you will get those two commit changes whatever are there. Okay, that's called the merging. Okay, we'll see the merging later, but let's try to complete the branching part completely. Okay, now I created one branch, I made some changes, and I explained you how to make some commits and push it, right? So what else is there in branching? Okay, a Git branch will show you a list of branches. Git branch -a. What do you mean by Git branch -a is? It will show you the remote branches as well. See, can you see? These two are your local branches, release one and master, and these are all your remote branches. Remote nothing but your server branches. Okay, and Git branch -r. This will give you only remote branches. Okay, and this is to create a branch, and this is to check out the branch, and how to rename a branch. Okay, now I have release one, right? I want to rename it. Okay, Git branch release one. I wanted to rename it with R1. You can do that. Sorry, you need to provide -m, guys, to do that. That's it. Okay, now you run the git branch command. Can you see it's become R1 now? That's called a renaming. You just follow this document, guys, straightforward. Okay, there is nothing over there. Now how to rename it and how to delete a branch. So now I want to delete a branch. Okay, so git push. Okay, sorry, git branch. What is it? Yeah, git branch -d R1. I want to delete this branch. Cannot delete the branch which you are currently on. Yeah, of course you cannot delete it. The reason it is, to delete a branch, right? Anytime, remember, to delete a branch, you shouldn't be there in that branch. Where are you right now? In R1. See, you are there in your own branch and you're trying to delete yourself, which is impossible. So you should be there in some other branch. Okay. Right now, the some other branch is master for me. So be there in the master, and what you do is git branch -d. Okay. R1. You run this. Now your branch is deleted. It's not deleted again now. Okay. Why it is not deleted? The R1 is not fully merged. What exactly it's trying to complain you is, see, this is not merged with your master. So you have some leftover commits are there. Are you sure you really want to delete it? Okay. It is asking you, are you sure you really want to delete it? Okay. So if you really want to forcefully delete, I don't know, if you don't want the commit, make use of capital D. Can you see this here? Capital D. It was small d earlier. Now make use of capital D. Now it is forcefully deleted. Now once forcefully deleted, it is deleted in your local repository, but not in your remote repository. See, but if you go to the remote repository, you still have that branch here. Okay, it's with the name of release one. Now let's try to push that. Git push origin R1. You might be thinking, what is the difference between earlier and this one? Okay, see, earlier one is you don't put any colon. Okay, now this one you are putting a colon, and forgot to delete one more thing, guys. We renamed the branch, right? This R1 is not there over here, so it cannot delete it. What is the name of the branch over here? Release one. So try to provide release one. Okay, now it is deleted over here as well. That's it. It's gone now. Disappear. So this is how we create a branch, and we make some changes, and we can delete it, and we can rename as well. Okay. So these are all about the branching stuff. Okay. And other section, I'll come back to the merging later. Let me complete this tagging stuff as well. Okay. Guys, you there? Any questions still here? All of you. Any questions? Which creating branches?
No.
Okay. So let's talk something about tags. Okay. A tag is nothing but a snapshot, guys. Okay. So whenever assume like you are three. Look at the log here, Git log. Okay. You have three revision numbers. Now what exactly tag is? Tomorrow it will become like 50,000 revision numbers or 50,000 SHA and sums. Okay. Now if you want to remember a particular revision number, can you tell me one thing? Can anybody remember this number? Which is really quite impossible and like really difficult to remember. Not impossible, difficult to remember. Okay. So to make your life easier, there are some milestones are there. Now assume like this, with this revision number you completed one deployment. Okay. And you want to record that. Okay. Recording this SHA and sum is it's kind of like a difficult task, and nobody wants to like remember this. Okay. So instead of that, if you want to give a name to a SHA and sum, name nothing but a proper name. See, if I wanted to identify any one of you, you have a name, right? Some name like Mahendra, Srinivas. So Srinivas nothing but, so you are, that is your name. Okay. So some identity for you. So similarly, a tag nothing but tagging a particular SHA and sum. So tagging nothing but giving a name to a particular revision number. That's it. Okay, nothing else. So now I wanted to tag this 5560. How to tag it? Or I wanted to tag this thing. Okay. So be there on this revision number. So if you are in master nothing but, you are in this revision number, latest revision number, guys. Okay. So let's try to create a tag. Git tag. Okay. And version 1.0. That's it. A tag has been created, guys. Okay. Now you might be thinking on which revision number this tag is created. The tag is created for the latest revision number, which is 63A, because you are there in the latest revision number. If you are there in the master nothing but, you are there in this revision number. Okay. If you wanted to see the list of tags, take git tag minus list. You can see all the tags. How many tags are there? Only one, v1.0. Okay. Now I will explain you. Git show v1.0. Okay. Just look at this. Git show v1.0 nothing but, now I'm trying to show you v1.0 tag details. See, this v1.0 nothing but this commit 63A94. Am I right? Just look at it. On which region number it is created? 63A98. Did you get it now? Okay. So it is successfully created a tag on top of this. Okay. And this is the revision number. Now this revision number is having a special name called v1.0. So similarly, you can create tags on previous revision numbers as well. Now git log. Okay. Now I want to create a tag on this revision number. How to create it? Okay. So to create that, what you're supposed to do, you first go to that revision number. Okay. Now let me go to that revision number. You know how to go to a particular revision number. Git checkout that revision number. Now you are in that revision number. You can check it out whether you are there or not. Can you see this here in your prompt? Now git tag. Okay. I would say we old, something like old tag, some name I'm giving. Now for this tag, I mean earlier was a one type of tag which is just a plain tag. Okay. It just tags a revision number. Now this tag I'm creating with some metadata, nothing but I'm just trying to give some more details about my tag, like a special tag. Treat it like a some surname. Okay. You are, see, the earlier one is the name and this is a name with surname. Okay. So creating a tag on first commit, something like this. That's it. Okay. Now this tag has been created. Now if you want to cross check list, you have two tags, v1.0 old tag. Now let's see git show old tag. Okay, can you see git show old tag? The tag name is what? Old tag. Okay, it is little bit more descriptive. Okay, now in this description it is captured the revision number this. Okay, so in earlier tag it is having only this information. In a named tag, which is with after you added some more message, right? The message is shown here. Okay, creating a tag on my first commit, and who did the tagging? Myself. When did I do it? February 4th. Okay, on which commit I did it? And this commit, and when this commit is done? On February 3rd. And who committed? Admin. So you have entire metadata here. Okay, So we can create these tags to remember some snapshot. Okay, tags are a kind of a snapshot, and you know what, tags can be pushed to a remote repository. Now right now you don't have any tags over here, right? Now what I will do, I'll try to push this tag. Git push origin old tag. So pushing is same, just like how do you push a branch. Now try to refresh this. Can you see this guys? Tag symbol and you have old tag. Okay, and similarly we can push the other tag as well, v1.0. Now try to refresh this. Can you see v1.0? Okay, so this is having a special tag, like creating tag on first commit, but this doesn't have it. This is just like a revision number, it is taken care. Okay, it is showing the revision number comment. This is deleted readme is the revision number comment, that nothing else. Okay, so this is how we create a tag. And now somebody wants to delete a tag, same concept. If you want to delete a tag, don't be there in that tag, you come back to master or somewhere else, then you can delete the tag. Git tag -d something was there, I can't remember exactly what is the option to delete it. Yeah, -d, that's it, just like a git branch -d. Now I want to delete v1.0. Now I deleted, right? Now git tag minus list, it is deleted, but it is not deleted in your remote repository. It is still existing in your remote repository. You can check it out. v1.0 is there. Now to delete it in a remote repository, same concept, git push origin. What is it? v1.0. That's it. It's deleted now in your remote repository. Okay. So this is all about tagging, guys. Okay, how to create a tag, how to create a named tag, and how to push a tag, and how to delete a tag, blah blah blah. Okay, so just go through those commands. It will be really easy actually. So you know to think much about that. Git show. There is one more command, git blame is there. Okay, git blame is nothing. It's a pretty simple command. Git blame. Uh, it will show you which user is modified the file. Right now, no user is modified. Let me do some changes. Okay, echo hello. I'm there. Hello text. Okay, so spelling mistake, echo spelling mistake. I'm making some changes. Git add. Hyphen updated. Hello.txt. Okay. Now you run the git blame command. You will be knowing who made changes on that. Can you see this? Chiranjeevi made the changes with this revision number on this. So if somebody modified again, so somebody modified this file 10 times, the 10 people name will be shown over there. Okay, so that it will be easy for to keep track of it, like who is modifying the file. That's a git blame one. Okay. Now what is stashing? Stashing is a really nice concept, which is there only in the Git. It is not available in your SVN or CVS and all. Okay. So what do you mean by stashing? Now to understand the stashing, come back to our workflow diagram. Where is it? We close that workflow diagram, right? Okay, fine. Let me go back to that. Git arc. Not like this. I want to open as a paint. Okay. Look at this, guys. What do you mean by stash is? Suppose, okay, you are in this state, the second state. Can you see this? You are in this state. You added some files into a tracked state. Tracked state, nothing but you created a file and you added it, but you didn't commit it. Remember, you created a file, you added it, but you did not commit it. Okay, now you're in this state right now. Assume if you're in that state. Let me try to create some files. Okay, git status. My workspace is clean now. Okay, and how many files I have it at the moment here now? Only one file. Let me try to create a new file called echo hello hi.txt. Okay, one file, right? Now this file, in which state it is there at the moment? Created state, the first state. Now let me try to add this. Git add hi.txt. Now this is in a tracked state or staging state, which is in second state. Okay. Now similarly I made one more change. Okay, that's it. One change is there, guys. Okay. Now what happened? I don't want this file to be committed. At this state, I don't want this file to be committed. I want to remove it. Okay. How to remove from the staged state? Okay. I don't want this file to be there over here at the moment. Okay. I want to delete it. So to do that, what you can do it, you can run a command called git stash enter. That's it. It cleans up your staged state. Okay. That's it. Now you try to run the git status command. Can you see this? No hide.txt, nothing. Can you see no hide.txt? It's cleaned up. So if you wanted to remove the added or tracked or staged files from your local workspace, okay, you can run a command called git stash and that will wipe away your files. Okay, it doesn't wipe away actually. It will keep it in memory, guys. Okay, it will not wipe away. Now suddenly if you think you wiped out, okay, suddenly what happened? I realized like I want the hide.txt back. Do you think it is easy to get it? Okay, so if it is typically delete, right, you can't get it back, but as it is a stash, okay, you can get that back. Okay, how you can get it back? Let me show you that. Git stash hyphen hyphen git stash list. Okay, so when you do it, when you run a stash, right, it will create some stack. Okay, so right now only one file has been stashed. Okay, so that you can see it over here. Okay, updated hello.txt something blah 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 is there. So you stashed it, there is only one stash is there. Assume like you are making one more change. Okay, echo hi abc.txt, a new file, git add abc.txt. Okay, now git status. Now this file also I don't want it. You can stash it. Now git status. It's clean now. Okay, now you look at the git stash list. You have two in the stack actually. Okay, one is stash 0, one is a stash 1. So whenever you perform like you run the stash command, whatever the stage or tracked items are there, it will move it into this memory and it cleans up your workspace. Okay. Now, in case if you wanted to get that back, okay, what you're supposed to do is git stash apply, okay, and you take the stash ID. This is what your stash ID, copy and paste it, and when you do this, right, you will get your file back. Git stash apply. Can you see this? You got your abc.txt file back. Okay, so similarly git stash. Okay, now once you get it back, right, now you look at the git stash hyphen list. Okay, you still have that. Now once you get the file back, you don't want it to maintain this over here, right? You can delete that. Git stash hyphen d something is there. Let me see what is the syntax of it. How to delete a stash? Okay, it's not delete, it's a drop. Git stash drop, and I don't want that. Drop it. Drop nothing but delete from the memory because you downloaded already in your workspace. Now you have only one over there in your list. Okay, guys, don't think like it is 0. If one is deleted, it will become 0, the other one. Okay, so it will keep increment that. Now that's good. Okay, now you have abc.txt. Okay, now you can work. Now if you want the other one as well, so same concept. Okay, git stash apply, you get it. So instead of git stash apply, there is one more command is there, git stash pop. Pop nothing but the latest one, it will download it. Okay, so right, and it's not only downloads, with the help of pop, right, the advantage is it downloads from the memory, at the same time it deletes from the stash. Okay, I'm not running the git stash pop now. Look at the git stash list, guys. You have a one item there in your stack. Okay, now when you run the git stash pop, right, it will download that item which is hi.txt. Okay, and it deletes in memory as well. Can you see this? It is downloaded the hi.txt and it is dropping that as well. Now you try to run the git stash list, empty, nothing is there. Okay, the advantage of with the git stash pop is it downloads and deletes, but with git applies it downloads, it won't delete. So to delete you need to run one more command. So this is all about this stashing. Now if you wanted to commit this files, you can commit it, guys. Okay, so stashing file something like that on master. And remember one thing, once you committed, you cross the state. Now you are in this state, guys. Okay, in this state if you want to stash, it won't work. Okay, stash works only with the staged files. Once it is committed, that's it. You cannot stash it, you cannot move it into memory. Okay, that's called stashing. Really important concept. people, if they really want to ask some questions on Git, right, they'll definitely ask about the stashing. They'll ask you like, in which state you can run a stash, okay, which files you can send it to stash, and you know how to get the stash files from back to your workspace. So because this concept is not there in the SVN, this is special to your Git, and which is one of the feature of the Git, okay. See, for the developer point of view, how it is useful is, developer did like some 4 programs he written. Okay, suddenly his lead said like he don't want that code. Somebody's already completed that code. So and he wants to work on new code. Okay, so but he already modified all the files. Now at this point of time, he don't want those files. So what he can do, he can make a stash. But after 1-2 hours, if the same tech lead comes and say like sorry, I missed like that guy didn't commit it. Could you please revert your changes and push it back? So if you would have really deleted, right, okay, what will happen? You need to rewrite the code entire. Instead of that, if you would have stashed it, right, you can pull that back. It's pretty easy. So that's the reason stash was implemented or stash was provided in your Git. Okay. So any questions with stash? Were you able to follow? I mean, is it easy to understand the stashing? Kiran, Mahander, is it easy to follow stashing?
Yeah.
Okay, the definition is written over here in the
Was
document. Yeah, you can read it out. Stash stores the stage changes into your package and stores in memory. Whenever you wanted to pull remote changes and wanted to apply on your unstaged changes, you can do this. Okay, so that's about the stashing, guys. Okay, so next, suppose you have some changes over here and you don't want them. If you wanted to delete them, okay, so how to do that? Okay, and this state we call as the untracked state. Okay, so untracked state nothing but like I touch a new file, I'm creating it. Okay, touch yy.txt and git status, guys, which state it is there in this file now? In untracked. You can see somewhere untracked written. Okay, yeah, untracked or unstaged is this first state. In first state, if you want to delete that file, if you want to remove it, right, you can run a command called git clean -f. That's it. It's smooth. And you run the git status, it's gone. Okay, so guys, this won't work like a stash keeping in a memory. It's a delete, nothing but delete. Okay, so here we just need to delete it. That's it. And I can note down these commands over here so it is easy for you. Git clean -f, and here it is a git stash. Okay, that's about the cleaning. Okay, I need to explain you one more thing, fetch and pull. Okay, so to explain this, what I would need is, see, this is developer A, treat it like this guy is a dev A. Okay, now this guy is a dev B. Okay, now I was saying like this guy can get the changes with the help of the git pull. So let's get one more git bash. Okay, treat it like he's your second developer. Okay, new prompt, Devops, git practice, git clone. Okay, now I need to have a different username and password, different account I would need it. Okay, so to get a different account, it's pretty easy. You can create an account from here, just like in SVN. How do you create a new account? So you go to the users. Can you see users here? And I can create a new user. Create a new user. Okay, and I can create a user called Harry, and the password is Harry, and the password is Harry again. Display name is Harry, and email address is harry@gmail. Creating an account is pretty easier. You don't run any command and all. You can just fill up a sign up form over here and save it. Okay. Now go to the access permissions and try to choose the repository. Which repository you want to give access? Devops. Okay. And what access you want to give it? Read write access. Just add it and save it. This is not working sometimes, throwing some errors, but anyway, you can just try it out one more time. Go to the users, Harry, edit it. Okay, go to the access permissions and choose DevOps, read write access, add, save. That's it, guys. Now a new user has been created. Now let's try to log into the new user with the help of the new user, 192.168.80.80. And now what is the username password for this account? Harry, right? So Harry, enter. Okay, now this time Harry, a normal user, logged in, guys. Okay, now go to repositories. Now Harry is trying to clone it out. See, for everyone the dashboard is same, whether it's admin or Harry and all. But only thing is, for admin you see so many options. This is normal user, Harry. That's the reason you don't have many options. But if it is admin, you look at this. You have a number of other options, users, teams. You can manage so many things, right? Now in a repositories, okay, with a Harry, right? You choose Harry this part. Okay, now what I will do it, guys. I would better say Harry from Linux machine, not from Windows machine. Okay, Control Z. Okay, so this is some new machine, guys. This is a developer machine. Treat this guy as a Harry. Okay, now this guy is trying to, like, git clone Devops. What is the Harry password? Harry, right? Password. That's it. Devops is clone. Yeah. Any questions? I'm just doing it in a Linux machine, nothing else. Did you get it, or
No
any question?
questions.
Yeah. Okay. So
No.
yeah, I'm in a Linux machine, and I cloned this repository. And before pushing or committing something, git config -- global. I'm setting my username like how I set it in my Windows, right? So my name is Harry, and my email ID is harry@gmail.com. Okay, this is a one-time task, okay, because it's a fresh machine, right? Email, right? So now let's make some changes over here. Okay, echo hi, I'm Harry. Okay, and harry.txt. I'm creating a new file. That's it. Can you see new file harry.txt? Now git add harry.txt, git commit -m. I'm from Harry. Okay, something I written there. Okay, now git push Harry. What happened? Login attempt failed. Invalid credentials. Harry. Something wrong, guys. Let me push it again. Git push Harry. Okay, this is pushed properly. I gave a proper password. It pushed properly, right? Now you can cross check whether it is really pushed properly or not. Can you see Harry pushed just now? Okay, and the file you can find in the tree section, harry.txt, right? Now come back to this user. You're this developer. You can close this. Okay, so this developer, does he have the harry.txt? No, he's become a little bit older now. Okay, so look at the diagram here. So this dev B is your Harry, guys. Okay, treated this guy as Harry. He made some changes and he pushed it. Okay, now in your remote repository you have a harry.txt. Now to get this harry.txt, developer A is supposed to run a command called git pull. Okay, so if he runs a command called git pull, okay, what will happen? The changes which are made by Harry will be downloaded into his local repository. Okay, so let's try to run that. Git pull. That's it. Okay, now merge. Yeah, okay, it is trying to merge something. Okay, can you see this harry.txt? Earlier it was not there. Now you got the harry.txt. So this is how you can pull the changes. Now there is one more command is there. Instead of git pull, people can do the git fetch as well. Okay, what do you mean by git fetch? To explain that, let me do something. Now when it comes to the developer A part, okay, my username part, let me make some changes. Okay, touch New York.txt, something, a new file I created, git add New York.txt. Okay, and git commit -m, some text file committed by Chiranjeevi. Right, now just try to push this. Right, now it's pushed. Okay, now it is available in your remote repository. So how this Harry will be getting that? Okay, so you might be thinking it's the same command, right? Git pull, then what is the difference? Yes, of course git pull will pull it. Okay, now instead of git pull, what I want to show it is, suppose Harry wants the remote changes, but he don't want to apply those changes on his workspace. See, he just want to cross check whether somebody made the changes or not. Cross checking nothing but are there any changes or not. So to cross check whether there are any changes or not, he can run a command called git fetch. What it will do, it will download the remote changes into his local repository, but it will not apply on workspace. Listen my statement properly. It will download the changes from remote repository, but it will not apply on his workspace. Nothing but he can't see the changes in your workspace, but it will download. Look at this. It is downloaded. Okay. You should be, and now you see this. Can you see neolog.txt? It is not applied. It is downloaded. Okay. So git fetch command will download, but it will not apply them. See, now it's fetching it. Now second time I'm running the fetching. Is it fetching anything? Nothing, because there are no changes. It's already fetched it. Okay. So that's what the difference between a fetch and a pull. A fetch command will downloads but doesn't apply. A pull command downloads and applies it. Okay. Now you might be thinking, okay, I want that file to be back here. So if you really want to apply that, you run the git pull command. That's it. Now you see this, you have a neolog.txt file. That's it. Okay. So this is about the fetch and the pull command difference, and this is important interview question. I've seen many interviews they ask this question: what is the difference between a fetch and a pull command? Okay, so you can find the answer over here. I mean, what I explained, you can explain to them, but still, you can just look at it in my document as well. Somewhere I would have written what is a fetch and a pull. Where is it? Where is it? Fetch. Yeah, git fetch and pull. Okay. Git pull command performs a git fetch and git merge. So what do you mean by git fetch is downloading, okay, and git merge nothing but applies it. The git fetch does not perform any operations on your local branches. What do you mean by does not perform any operations? It will not apply on your local branches, okay, it just downloads. That's called the fetch command, guys. Fine. So the last topic is merging in your Git, okay. So in the beginning we have seen the branching, right? Now it is the merging. Fine. So before I proceed, I wanted to just check with you guys. Are you fine? I mean, were you able to follow till now whatever I discussed with Git?
Yeah, fine.
Okay. So can I proceed with the merging, or is it okay to 1 hour for today?
Yes, yes.
Okay, fine. So let me proceed with the merging stuff.
Okay. Okay.
So where is the diagram? Here is the diagram. Okay. Now let's perform some branching strategy. Okay. So what exactly branching strategy is? Same thing like what we discussed in SVN. Assume a customer is there. We release one release. Okay. And before we release that release, the customer is coming back with another requirement. We call it the second release, third release. Okay. So how do we do the parallel releases? Okay. The same concept what we did in SVN, we'll try to do it in the Git as well. Okay. So, and we'll try to see how to do that merging as well, so that I can explain the merging stuff with a proper branching strategy. Okay. Now treat it like you are over here. Okay. Now what I will do it, just do it. Okay. So this is what your master. Okay. Now it's a time for you to take up all the new releases as part of the branching strategy. So now you wanted to create a new branch. Create a new branch. Okay. And you ask the people to work on it. Okay. And people have started working on it. Okay. Now at the same time, what happened? There might be another requirement to just move it. Okay. There might be another requirement for another release. Okay. So this is R1 and this is R2, release 2. Okay. Right. Now when R1 is finished, okay, it is supposed to merge it back to your master. That's what the main branching strategy concept, because your master is kind of a stable branch and it's a kind of your main branch where all the code will be there. All the code should be there. Okay. Okay. Now once you complete your release 2, right? Okay. Once you complete your release 2, or while before you complete your release 2, there might be another requirement, okay, for another set of releases. Okay. And that you called as the next release, R3. You made some commits. Okay. And this you call it as a R3. Got it. Okay. and after some time you would have finished the R2. So once you finish the R2, what will happen? You need to merge it you back to your master, so that you know your master contains all your R2 commits as well. Okay, see, now when you merge R1, right, it gets your R1 commits into your master. Okay, so this block of commits, when you after the merge, this block of commits are your R1 changes. Okay, right. Now similarly, when you merge R2 back to your master, right, you will get, okay, these three commits, these are belongs to your R2. Okay, so R2 changes will be merged. These are your R2 changes. Okay, now R3 is going on. So again, after some time when it comes to a release, it needs to merge. So this is a kind of a never-ending process. It keeps goes on. Like, you know, the people will be working on the multiple branches parallelly, and once they are done with the releases, they merge it back. Okay, so this is how the branching works, guys. Okay, now let me try to reproduce this in a practically on our repository. Okay. Git pull, just make sure you're up to date. I'm up to date. Git log, how many comments are there? Something like, you know, there are 1, 2, 3, 4. Some 4 comments are there. 1, 2, 3, 4. Yeah, some 5 comments are there. That's okay. Let's try to create a branch. Git branch R1. Okay. Now I created a branch and just check out to that branch R1. Okay. And what I'm trying to do it here is touch R1.txt. Okay, a new file I created, mkdir release 1 directory, a directory I created, and get into the directory and touch abc.txt file. Okay, now git status, some changes I made. Now let me add everything. Okay, if you want to add all of them, just put a dot, guys, it will add all of them. Okay, git status, it is added all of them, and try to commit it. Added r1.txt and some changes. Right, now this is my first commit, which is this one, guys. Look at my mouse over here, r1, this one. Right, now let me make one more commit. Let's have some couple of commits. Okay, this time what I will do it, git rm harry.txt. I'm trying to delete, I'm deleting also one commit. Okay, commit -m deleted harry.txt as part of r1 release. Right, finished. Right, now I'm in between the my development, but meanwhile what happened, from master I need to cut a new branch called release 2. So let's cut the new branch because there is a requirement. See, in the middle of the development of R1, I got a requirement to, like, you know, work on some other features. So check out to master and see, you need to create a branch from master. So you should be there in the master. Branch R2. Now I created branch R2. Now R2 is also started working. Okay. So parallelly. So at one point of time, R2 RM both were working. Can you see this? Before they merged, at this point of time, both were working, right? R2 and R1. Okay, so let's check out to the R2. Okay, and make some changes. Touch r2.txt. Okay, git add r2.txt, git commit -m added r2.txt in r2 branch. Okay, some commits. Now switch it to R1. Okay, now I made one commit over here. Now switch it to R1. So treat it like, you know, R1 is done with his code changes. Okay, now it's time for R1 to go to production, and it pushed to production, and now he is supposed to merge it back to master. Okay, how to merge it back to master? So when you are merging, right, simply remember, okay, the concept of merging here is, git stash we are seeing, clean we are seeing, clean we are seeing, branch we are seeing. Okay, now merging. Okay, in merging, always be in destination. Be in destination, nothing but. Now your job is to merge R1 to master. It clearly says R1 is source, destination is what? Master. Okay, so be in destination nothing but you should check out to destination. Okay, so which is master. So check out to master, guys. Check out to master. Okay, now once you check out to master, try to run a command called git merge and the source. Okay, now this command I'm replacing with the actual values. What is the destination? Master. Git merge. What is the source? R1. That's it. It's pretty straightforward if you understand the concept. Okay, now git checkout R1. Okay, if you run this command, this will pull the changes from R1 to your master. Okay, I'm not running this command, guys. I cancel the command. Before running, I wanted to show you the log of master. Okay, in a log of master, what is the last commit, guys? Some text file committed by Chiranjeevi. This is 4568. This is what my last commit ID. Okay, in my log. And also, do you have any apart from these 5 files? Do you have any other files? Nothing. Okay. Now you run the git merge command and see git merge R1. See, the merge is successfully happened and try to run the ls command. Guys, you got at least one directory. You got r1.txt and your harry.txt has been deleted. It was there here now. Did you see? It is successfully merged everything into your master. Okay, without any problems. This is called merging. Okay, so everything we are doing in our local repository only. Now after you merge it, right, okay, you look at the git log command. Okay, so see this. The last commit was this is what to your master history. Okay, now what is happening here? These two commits came from where? Your R1 branch. Okay, so it just gets you the changes. Now this is a successful merge, so there is no merge commit actually. Okay, it just combine all your commits. Now sometimes what happens due to the conflicts, okay, right now there is no conflict, everything is happy flow. Okay, if there is any conflict, you need to resolve the conflict and you need to make a commit, and that commit we call as a merge commit. Now let's see that kind of a merge commit with R2 branch. Now we successfully merged R1 and everything is done, all are good. Now just check out your R2, guys. Okay, in R2, now what I want to do is echo hello uh, hi.txt, git add hi.txt, git commit -n. Okay, so some changes in R2. Okay, fine. Now let's try to merge this to your master. Git checkout master, git merge R2, merge R2. Yes, that's it. So now you can find R2 changes as well. Can you see? Merge R2 is like, this is one change and some changes in R2 and add R2.txt. Okay, so it is successfully merged into your master. So R2 has been merged back to your master. Okay, so this is how you keep merging it. Okay, once you complete changes, you just keep merging it. And I didn't show you any conflict situation. Let me create a conflict now. Okay, I'll try to create a conflict with our third branch. Now let's try to create another branch called git branch R3. Okay, now let me create another branch called git branch R4. Right, now two branches created at the same time. Okay, now what is happening? Let's go to R3. In R3, what files I have it? In R3 I have a hi.txt, right? Now what I will do, cat hi.txt. What changes you have here, guys? Hello, right? Now what I will do, Devops hi.txt, git add hi.txt, git commit -n, modified in R3. Okay, so now you check out to R4. In R4 also, assume like in R4 also, look at the cat hi.txt, hello is there. Now here, build management, okay, in hi.txt. I'm appending with the build management and third line. Okay, see, same line in R3 branch it is DevOps. In same line here it is a build management, right? Git add hi.txt and git commit -n. Okay, modify in R4. Okay, right, now you check out to your master branch. You first merge your, okay, R3 guys. This merge will go smoother, R3. Okay. Now git merge R4. Now you try to merge R4. This is what the conflict. The line in the same file has been, you got a conflict here. Can you see conflict here? Okay. So to resolve the conflicts, what you're supposed to do it, you have to run a command called git merge tool. When you run git merge tool, okay, this will pop up with a tool like tortoise merge. And remember, for you it will not show you this tortoise merge. You have to install the tortoise git tool. Okay, and that tortoise git tool you can find it in your you just go to the Google tortoise git, just like a tortoise system, just tortoise git. Try to download this. Okay, it's a small exe. Download and do next, so that will install it. Now once it is installed, right, you have to make a couple of changes guys. Okay, so what exactly those changes are, I'll show you. You go to your C users, okay, and your username Chiranjeevi Patel, and this, I mean, for your operating system, like whatever is your username. Git config, somewhere it should be there. Git config. Yeah, can you see git config? And go back to git config. You need to provide, no, not this. I think I'm in the wrong one. Yeah, that's the one. Git config. Hmm. Okay, enter. Yeah, I don't think you need to do anything guys. You just install the tortoise git and it will open a prompt like this. Now look at this. This is a merge window. Okay, so this merge window, now you need to merge. So what is this is build management. This is R4 branch, and this is local is what your master. Master is having the DevOps. Now this third file at the bottom is the resolution file. Now what do you want to do it? In four ways you can merge this file. Do you want to keep the server changes? I mean their changes, nothing but. Do you want to keep R4 changes, which is, it will keep only R4, which is the build management. It will override the DevOps. Now control Z. And do you want to keep only yours? You don't want the others. Okay. It will keep only DevOps, which is your changes. Okay. Your master changes. And the other one is, do you want to keep your changes and at the end your server changes, which is DevOps and build management. And the fourth option is, do you want to keep the server changes first and your changes later? It's up to you, whatever you want to try. So ultimately you're trying to resolve the file. Now I want to do this. Okay, now close it, save it. That's it, the merge has been completed. Now there will be a change on your hi.txt. So now this merge, you need to commit it. Okay, commit saying like merged R4 to master. That's it, git log. Can you see merged R4 to master? It's a new commit, and this is called a merge commit actually. Okay, whenever you get a conflict, what will happen? You may need to, you may have to I'll show you now how it works. See, when you merge R3, there is no conflict, successfully merged. Okay, and this is R4. This is R4, right? Now when you try to merge R4 to your master, what is happened, you got a conflict, so it's not a straight merge. Okay, so assume there is a commit here. Okay, only one commit. Now here you will get one commit, but you will get one more commit. Okay, this commit, and this commit we call as a merge commit. Okay, so this you will be getting merge commit only when there is a conflict. Okay, because you need to resolve, once resolved, the new file you need to add it, right? So that's the reason it's called as a merge commit. So this is all about the merging guys. Did you understand the merging? And in document you see command line merge, please don't follow this guys. Okay, so you just ignore these commands because you hyphen x and all, because the tortoise merge tool is a really nice tool. Most of the people use the GUI merging only, not the command line merging. Command line merging is dangerous because we cannot understand 100 lines code and 200 lines code conflicts and all. So you better go with the tortoise merge one. So if it is not working in your machine tortoise merge one, in the .git config, right, you have to put these lines. Okay, merge tool, these lines. Actually for me it is working without keeping those things. Okay, if you look at this .git config, right, in this .git config we need we need to put that. There is nothing like, these lines are there. See, these lines you need to copy and keep it in your .config actually. This is how you need to keep it. But without them also, mine is working. In case for you if it is not working, you keep these lines in your .git config file. Okay. So where are we? So that's about the merge, and there is two more are there with merge. One is the rebase, another is the cherry pick. Okay. So what is rebase? Okay. So rebase is something like a new thing in Git, not like in SVN we don't have a rebase concept. Okay. What exactly rebase is? Rebase is also another type of merge. Okay. Let me explain you that. People will confuse between rebase and merge, but mergings are three types. One is straightforward merge, another is the rebase, another is the cherry pick. Okay, this is in the Git. This merge we have seen, so there will be a merge commit for sure. Okay, and rebase is also a merge. There is no merge commit in rebase. That's the difference. There is no merge commit in rebase. So rebase will adjust all its changes back and forth. Okay, but it will not create any commit over here. It will mix up all your commits into this one single branch, but it will not create any kind of a merge commit. That's a rebase. Now how it works, I'll show you now. Git branch RB1. I just created a new branch called RB1. Just check out RB1. Say touch RB1.txt file. Git add RB1.txt file. Okay. Git commit -m added RB1.txt file. Okay. Now let me make one more change. Echo hello hi.txt git add hi.txt git commit -m modified hi.txt in RB1 branch. So I made two changes here. Git log you. If you look at this, these two commits are over there in your RB1 branch. Okay. So now git checkout destination, same process, just like a merge. Git checkout master. Okay. Now git rebase RB1. Now it will pull all those RB1 changes just like a merge only. Sorry, I'm not there in the master branch, guys. Git checkout, spelling mistake. Git checkout RB1. Checkout at master and RB1. So look at this. It's mixed all your commits from your RB1 branch to here. Now you look at your master. You got all those changes. Did you see this? You got all those changes. It's mixed your RB1 changes. Okay. It will not create any kind of a merge actually. Okay. Any kind of a merge commit is not created. That's a difference between the merge and this. Merge will create a commit over there, but here you won't be there won't be any kind of a merge commit. It just mixes it. Okay. So you might be thinking, then why we have both? See, in few scenarios, developers will rebase actually. The purpose of rebase is like, if you have very few couple of commits, you don't want a separate history to be maintained for that. Okay, then you can make use of the rebase one. And suppose you are working on some 2 months project in a separate branch. Okay, and don't do the rebase for that branch, because if you try to rebase that branch, right, all those commits are mixed in your master and you cannot recognize from where to where this branch has been developed. Okay, you won't be having any merge commit. So that's the reason when you have a lengthier commit changes, when you have like more number of commits or lengthier branch, right, go for the merge. Short term branch, couple of commits, go for the rebase. Okay, so that's a recommended approach for the developers, but it's up to them. Okay, most of the developers will go with the merge guys. Okay, they don't want to play around with the rebase and all. So that's about the rebase. And the third one is the cherry picking. What do you mean by cherry picking is, see, the rebase, the merge and all, what they do it, what are all the commits are there here, n number of commits in branch. Everything is merged back to the what are the branch you wanted to merge it. But in cherry picking, what will happen, assume from here, you create a new branch called cherry branch. Okay, now you made some commits, 3 commits or some commits. Okay, now in master, what is happening? You may need some changes from cherry picking, but not all of them. Okay, what I'm trying to say is you may need some changes. Assume I want this change. Okay, only one revision number if you wanted to merge, right? That we call as a cherry picking. Only one revision number. These 2 revision numbers will not be coming. Only one revision number if you want to merge it to your branch. That concept we call as a cherry picking. Okay, so these 2 will not be merged here. Only one. So taking only one revision number is called cherry picking. So let's see how to do that. Git branch cp1 cherry, let me create cp1. Okay, so git checkout cp1, right? Now touch cherry.txt. Okay, git add cherry.txt, git commit -m, added cherry.txt. Let me make one more change. Okay, touch cherry1.txt. Okay, git add git commit -m, added cherry1.txt. So if you look at this, I made 2 commits here, 1, 2. Okay, let me make one more commit. Touch 12345.txt, some file name guys. Okay, git add. Okay, git commit -m, added 1234.txt. Okay, so I have 3 commits. Now go back to your master. Git checkout master. Look at your log in master. You are in the previous log as usual, modified h1, rb1, rebase 1. So these things are there. Now if you look at the git checkout cp1, go to cp1 and look at the cp1 log. Can you see this? You have 3 commits. One is added 1, 2, 3, 4, cherry 1, cherry. So these 3 commits are there on your cherry pick branch. Okay, now go back to your master again. Git checkout master. Okay, now git merge. Now if you wanted to get only the 1234.txt file, what you're supposed to do, take that 1234.txt revision number. Okay, can you see this shown? Some take this, copy. Okay, get cherry pick, not merges. Okay, git cherry pick. Yes. That's it. Now in a master, right? Look at this. You got that file already. Try to run ls. Did you see this 1234.txt? Only that. You didn't get the cherry.txt, cherry1.txt. And when you look at the log, you got only that revision 1, 2, 3, 4. You didn't get the other 2. This is called cherry picking. Okay, getting a particular revision number, merging into. Getting a particular revision number changes into your branch. Okay, so that's it. It's a simple concept, cherry picking. See, you can point to master to some other single commit. Okay, that's it. What else? Yeah, path set. So with path set, we are. If you are done with the path set, then we are almost done, guys. Okay. So to explain the path sets, right? Come back to the architecture diagram here. See, I explain git clean command to clean up the untracked files, and explain git stash command to clean up your stacked files. Okay. Suppose there is, assume there is a developer over here. There is another developer over here. Okay, and he is having a local repository. He is having a local repository, okay, and he has a workspace as well. He has a workspace as well. Okay. Now, what I'm trying to explain to you is, see, this developer is there, right? Okay. He is also having a workspace. Sorry. He is also having a workspace. Okay. Now, this developer committed some files, pushed some files. Okay. Pushed some files, and those are all total 3 commits, guys. Okay. So 3 commits are there here. Now, these 3 commits, assume like this developer wants. Okay. He is something like Sally, and he is a John. Okay. Now, Sally wants John's 3 commits. Okay. And to get those commits, what exactly is supposed to happen, guys? First, John's supposed to push the changes to to remote repository, and Sally is supposed to pull it. This is what the ideal approach, like you and me, everybody knows it. Okay. Now, what I'm trying to say is, without touching remote repository, okay, before pushing into the remote repository, would you please share all your 3 commits directly to Sally, okay, in his workspace, okay, and so that he gonna verify those commits. If you feel those commits are fine, then you can start pushing it. Treat it like Sally is a tech lead and he is a normal developer. So the tech lead is saying the normal developer, send me your 3 commits, I'll verify in my local workspace. If I say go ahead, then you push it. So how do I get 3 commits into the other machine workspace? This is what the question. Okay. So to get that, what we can do is these 3 commits, we can make it in the form of a path sets, and those path sets we can give it to the Sally, and Sally can apply in his workspace and he can work on it. Okay. So how to create this path set? So let me show you how to create those path sets. So come back to here, the workspace. Okay. Now try to push whatever you have it here, everything. Now I pushed everything. Okay. Now what I will do, I'll make couple of commits. Okay. Echo hi patch1.txt. I just create a file. Git add patch1.txt. Git commit -m added patch1.txt. Right? I made one commit. Look at this. I made one commit which is not pushed. Right? You can see that. See, there is a commit, but which is not pushed. One commit. Now, let me make one more change. Git rm1234. I'm deleting this file. Okay. So git commit -m deleted 1234.txt. Right? Now this is another commit. In this commit I deleted the file. So total how many commits, guys? 2 commits. 2 commits are there. You can see 2 commits. Now these 2 commits are not pushed to your remote repository. Now what I wanted to do it, I wanted to share these 2 commits with my developer. Okay. My lead who is Sally. Okay. So how to share my 2 commits? So to share your 2 commits, what you're supposed to do it, you have to run a command called patch. Something is there, the syntax. What is it? Format patch. Format patch origin, and where are you right now? Master, the branch name. That's it. Now can you see it is created 2 path sets? Okay, 001, 002. Now what you're supposed to do it, these 2 path sets, okay, these 2 path sets, you need to send it to Sally's machine. So how do you send it? It's up to you. You share through email, or you share through Skype, or you share through some FTP, doesn't matter. Now let's take this is what our Sally, guys. Okay. Now git pull. Okay. Now look at this. You have 1, 2, 3, 4. Everything is there. Now treat this is what I mean. This Linux machine is your. I mean this guy is your tech lead. Now you want to share your files with him. So I think we can make use of scp command. Okay. 00 star vagrant 192.168.33.10. Okay. Where do you want to copy? You just take this path, paste it, Vagrant. That's it. Now you have those files here. Okay. Now I have the path sets. I have the path set. Now you look at the git log. You have like either 1, 2, 3, 4. All these things are there. Okay. Now to apply the path set, what you're supposed to do it, git apply path set, something was there. What is it? Git apply, right? Yeah. Git apply 001. Okay. What is 001, guys? It is like in this commit you have a patch1.txt file. When you run this, it is successfully applied. To know to see the differences, look at this. Uh, can you see patch1.txt anywhere? Yep, patch1.txt. Is it there earlier before applying the patch? No. This is how he can get the commits and he can apply and he can see the files. Now 1234.txt is there. Now let me apply the second patch set. That will be deleted now, because the second commit is what, deleting the this 1234.txt file. Now this is also applied. Now just try to run this. Can you see 1234.txt here? No. So this is how you can share your chain set with somebody else, okay, your commits in a form of a patch set, so that they can apply and they can check it out. Now once they verify this, okay, yeah, the things are good, now it's ready for you to you can push it. Then what this guy can do it, he can push it. You might be thinking he can push it and he can pull it, right? Why this wrong up, I mean, kind of shortcut approach, creating a patch sets. And see, it's something this guy don't want these guys to push some shit and all into the main repository. Okay, he wants it to push some quality code. Okay, he wants to verify that code, so that's the reason he has those commits and he verified it. Then he is asking him to now you can push it. Okay, so maybe somebody may follow this kind of approach, we don't know, right? But if your system tool is supporting you, then utilize it. Okay, so this is all about the path sets. Any questions still here? Kiran and Mahendra, do you understand the path set?
No, no. Yes, sir.
Okay, good. So yep, that's it, guys, with the git version controlling system. Okay, so we are pretty much done with the git. And what else is there? Yeah, only thing is, from your end I want you to practice it well and come up with your questions. Okay, just ask me if you have any
Oh,
questions. So tomorrow we'll start with a new topic. We are done with the source code management stuff, the first topic of our session, and we'll go to the second topic, which is a build process automation. And we'll be starting with a Java project build with the help of the Apache Ant. Okay, and I'm going to conduct the session tomorrow same time. Your time is 9 o'clock. Okay, is it fine?
okay. Okay, okay.
Okay, cool. So we'll catch up tomorrow, guys. That's it for today. See you then. Good night.
Can you please upload the yesterday's video?
I think it's already uploaded. You just check it out. Is it not?
Okay, okay. Thank you.
Yeah, I'll check it out. If it's not uploaded, I'll do it. Okay, don't worry.
Okay, okay.
Okay then. See you all.